What's up guys, Patrick here, welcome back. Moving on to the next question. We got to find the limit as x approaches 0 of 3 times cos inverse x minus 3 pi over 2 all over x. So first thing you want to try with the limit, let's do a direct substitution. Now as x approaches 0 of this cos inverse x, let's do a quick review on that. By the way, this cos inverse x could have also been written as arc cos x, so just be on the lookout for that. Both of them are the same thing. But as a quick review, this cos inverse x, the way it looks is we got -1, we got +1, and then we got 2 points here, and it looks something like that, where this y value is pi, this is 0, and then this here in the middle is pi over 2. So cos inverse 0, when x is 0, which is here, what's the value of the function going to be? It's going to be pi over 2. So what we would end up having is 3 times pi over 2, which is 3 pi over 2, minus 3 pi over 2, which is 0. And then notice the denominator is going to be 0 as well. So unfortunately, can't do a direct substitution. It's in indeterminate form. But because it's in this format, 0 over 0, we could try maybe L'Hopital's rule. So what we would do is we would take the derivative of the top, the numerator. Now, the derivative of cos inverse x, as a quick review, if you got cos inverse x, the derivative of that is -1 over the square root of 1 minus x squared. And then the derivative of this 3 pi over 2 is just a constant, it's going to be 0. So what we would end up with in the numerator, this constant stays, and then the derivative of this is this over here. And then what's the derivative of x? The derivative of x is just 1, so this is all going to be divided by 1. So we don't even have to write that. And now notice we could do a direct substitution. We could plug in 0 for x. This would go to 0. Square root of 1 is 1. -1 divided by 1 is -1. Times 3 gives us -3. Right? So that's the answer to this, this limit here. You just had to apply L'Hopital's rule.